Hey guys, today's lesson is all about properties and operations. And you can see I have the three listed here that we're going to, actually there's six. If you consider that for each one of these I have an addition and a multiplication. So that would mean there's actually six properties because there's two properties for each one of these three. Number one, the associative property of addition, or it could be the associative property of multiplication. Two is the commutative property of addition and multiplication. Three is the identity property of addition and multiplication. And I guess the thing that I point out to you guys is these properties that we're going to be learning today, the three that are here, these are all things that you guys know how to do already. When we're solving problems, you are already doing these three things. We're just taking it today to actually put these names to the actual physical operations that you're going to be doing. If you notice here on these three rules that we have, as I already pointed out, it's always either going to be these properties of addition or they could be properties of multiplication. We really don't have them for subtraction and division because what we're going to learn today is these properties do not work if there's a subtraction or division. It's different. So everything today is going to be adding or multiplying. Okay, so let's learn about these three properties. The first one here, called the associative property, and again, it could be one of two things. It could be of addition or it could be multiplication. It just kind of depends on what the problem is. So the first one I'm going to point out here is if we did something like this. If I had 9 plus 6 and then plus 2. Okay. Now, when we're going to do this, of course, these properties are going to take place anytime in this problem because everything's multiplication. Of course, if you're doing expressions that have, adding, subtracting, multiplying, and dividing it, then we have to revert back to our order of operations to tell us what to do. But the things that we're learning today are going to be all when everything's going to be adding, or there might be a problem where everything's being multiplied. And in that case, there's some special things that we can do here. Okay, now I'm just going to put an equal sign on here, and I'm going to write these same numbers again. 9 plus 6 plus 2. Okay, what the associative property says is this. Really, when it's all addition like this, when there's three numbers or more numbers, because it's all addition, it really makes no difference which ones we add together first. So if I look at the first half of the equation here, let's just say here I want to put parentheses around the first two and do 9 plus 6 plus 2. Well, if we were to go ahead and solve that, we would have to do parentheses first, which tells me 9 plus 6, which is 15. And then if I went ahead and added on the 2, we would get an answer of 17. Well, what we're trying to say here in the associative property today is this. Even though I did 9 plus 6 together first on that side, what if I chose I didn't want to do that first? Maybe I wanted to try to add these second two things together. Is that going to make a difference? Well, if we did that, we'd do 6 plus 2, which gives me 8. And then I'd still have the 9 plus 8, which again is going to give me 17, which still makes these two things equal. And that's the whole point of this property, guys, is because everything's being added, they're saying it doesn't matter which two that you add together first. So again, the associative property, and this is what you're going to have to look for today, is because everything's addition, they're saying, okay, I can add the 9 plus 6 together if I so choose, or we can choose that 6 plus 2 together first and then go back and get the 9. Makes no difference. One big thing I want to point out on this is notice that I never rearranged any of the numbers. Okay, I didn't take the 9 and the 6 and flip them around and write it as 6 plus 9. I'm not doing that. That's a different property when we do that. Basically, I have the exact same order here and here. I just decided to put parentheses around two of the different numbers so that I added it differently. Okay, so this one here would be the associative property of addition because everything's being added. The only difference when it's multiplication is that there's actually numbers being multiplied instead of adding. So again, if I write down a problem here, if I did 2 times 3, and let's put that in parentheses, times 4, that's going to be the exact same thing as, again, if I write down these same things, the 2, the 3, and the 4, but then I'm saying rather than like on the left-hand side where I do the 2 times the 3 first, on the right-hand side I'm going to do the 3 times the 4 first. So again, I'm not changing the order of the numbers. They're still written in order, 2, 3, 4, 2, 3, 4, but it's just which one I'm choosing to multiply together first. And if we did this over here, I do 2 times 3, which is 6, and then that 6 times 4, which is going to be 24. And of course, on the right, we're going to get the same thing. If I do the 3 times the 4 first, we get 12, and then we go 12 times 2, you're still going to get 24. So the point is, you're still going to get the same answer. It's just that, in this case, because everything's being multiplied, they're saying you don't necessarily have to work left to right. You don't always have to do the first 2 numbers. If you want to choose to multiply the second 2 first, that's fine. Okay. Next property is called the commutative property of adding and multiplication. So same as before, there are 2 types here. It's going to be the commutative property of addition if in the problem everything's being added. Different property is commutative property of multiplication, and that's if the problem has everything that's being multiplied. So let's go ahead and look at those 2 things. So we'll keep it fairly simple here. If I do 4 plus negative 7, okay, which is something that we've been working on, integers, we know how to solve that problem. Okay, if I did 4 plus negative 7, we would get an answer of negative 3. What we're saying today, though, is the property, the commutative property, is if I actually want to go ahead and change these things. If I want to rewrite this and say negative 7 plus 4, so I'm actually physically flipping around the numbers. I'm moving negative 7 so that it comes first. I'm taking the 4 and make that come second. And you're going to see that it still doesn't change the problem, because when I do negative 7 plus 4, I still get a negative 3. So these 2 things are still equal. But what we're doing, the commutative property says when you actually take numbers and move, when you change their location, that's when it's going to be the commutative property. Again, I'm going to go back to the first property. The associative property here, when we looked at these numbers, let's just look up here. I never moved anything. It's still written in order, 9 plus 6 plus 2. And over here it's 9 plus 6 plus 2. I never actually changed the location of the numbers. In the commutative property, you're actually changing them around and rewriting them so a different number comes first and then the 4 came second. Okay? This one is the commutative property of addition, of course, because there is addition in the problem. It's the exact same thing, though, if we do the commutative property of multiplication, which says if I do 2 times 4, which we all know is 8, that's going to be the exact same thing as if you physically switched these around and did 4 times 2 is also 8. Okay, so what we're going to be doing is we're going to be showing you a couple of these today, and you're going to simply have to identify, well, which property is it? Okay, is it the associative property? Is it the commutative property? And then, of course, determine if it's adding or multiplication will be the easy part of it. Okay, so that's our second property. So number 1 was the associative property. Number 2 is the commutative property. And then finally we have the identity properties. Okay, again, these are things that you guys already take for granted and already know. But we're going to write it down so you have a name to go with the rule that you do. Just as if I do 9 plus 0. This is what we call the identity property of addition. Again, because it is addition, okay, very easy to tell. But the identity property is simply any time that you add 0 to a number and you get that exact same number as your answer. Okay, it's the identity property. It's the identity of the number. So if I take 9, I'm adding 0, you still get that same number again. Okay, identity property of multiplication now is if you're doing a multiplication problem, but the 5, I want it to become the same. So what do we have to multiply by? It's when you multiply by 1. Okay, and those are our identity properties. So basically, the identity property of addition is when it's an addition problem, you're adding 0 because that's what gives us that exact same number that we started with, the 9. The identity property of multiplication is whenever that you're multiplying a number times 1, because again, that gives us that answer that we already started with, the 5. Okay, guys, let's put you to the test. So example 1, identify each property. I have 4 of them here, an A, B, C, and a D. I simply want you guys to go through and identify what each property is. So pause the video, give it a try. Okay, we're back, everybody. Hopefully you have 4 answers written down in your notes. I'm simply going to go through and look at these things here and identify which properties they are. Hopefully yours matches up with mine. Okay, part A. I see that there's a multiplication there because we're multiplying by a 1. And actually that should be, I'm going to change this here. There should be a negative 5. Okay. And then when I multiply those together, negative 5 times 1 is a negative 5. So therefore, this is going to be the identity property. So I'm simply going to write that down. If I spell it right, of course. Identity property of, and this is multiplication. And I just, instead of writing out multiplication, I just put the little times box there. Okay, number 2, we have 2 plus negative 9 equals negative 9 plus 2. I see that it's an addition problem, so I know whatever property is, it's going to be a property of addition. So I can go ahead and write that down. The key to me here is this. We are actually flipping around which number comes first. On this side, it's 2 plus negative 9, and over here, we end up getting the negative 9 as first and then the 2. So because we actually change these things, that's what makes it the commutative property. Commutative property of addition, of course. Okay, on the third one here, if we do y to the second power, or y plus 2 equals y, again, I messed this up, guys. I'm going to change the problem. Now, let's just get rid of that. I'm going to try it again. Y to the second power plus 0 equals y. That's what it's supposed to say. I apologize for that. Okay, so if you gave that one a try, here's what ends up happening. Y to the second power plus 0 equals y. Again, because we're adding 0, that means it's an identity property. So this ends up being the identity property of, in this case it's addition, because we're adding 0. Again, I apologize for that mistake. Okay, part D, last one. This here is a multiplication. It's basically saying that if we multiply P and Q together first and then go ahead and multiply by that 2 that's out front, that should be the same thing as if we multiply the 2 and the P together and then go ahead and multiply by the G. Again, it's just kind of telling you that it doesn't matter what order you multiply these things in. So the key to me, though, is look at the order. Did the order actually change around? Meaning the 2 is listed first, then the P, and then the Q. So it goes 2, P, Q. On this side, 2, P, Q. So it's the same number and variables listed in the exact same order. Because we actually didn't flip anything around and change the location, that's, what makes this one the associative property. The associative property, and of course, because everything's being multiplied, that's the associative property of multiplication. Okay? Last problem. Evaluate each expression, justify your steps. So when you're doing these problems, if you get this on the homework, it's basically saying solve the problem. Evaluate means to solve. So I want to go ahead and do these problems and actually get a final answer. As far as the justify your steps go, again, a lot of people want to say justify your steps, basically saying as you solve the problem, you should be saying this is the associative property, this is commutative property. As far as I'm concerned, I don't care that you actually write those down. I just want you to solve it. And the way you're solving it is going to be justification enough for me. So go ahead and try to solve these problems on your own. Again, try to look for ways that maybe might be a little easier to solve it than what you normally do. So pause the video, give them a try. Okay, we're back. Again, right before we paused it, I said some things that we need to look at here is because I know everything's being multiplied in part A here, maybe I don't want to go right in order. It might be harder to take the 15 times the negative 9 and get that answer and then take that times 2. So what we want to look for is there another way that might be a little easier to help me out here? Like meaning, maybe I want to do the 15 times the 2. So if I switch around this, the negative 9 and the 2, this could become this, 15 times 2 times negative 9. That's what we call the commutative property because I actually flipped around the 2 and the negative 9. And the point of me doing that is because I know 15 times 2 is pretty easy. That gives me 30. And then if I take that times the negative 9, it just made my life a whole lot easier because 30 times 9 is going to be 270. And I know a positive times a negative gives me a negative, so it's a negative 270. Again, so I hope you see the point. We're trying to use these properties that we learned today to go ahead and solve these maybe in an easier manner. Okay, part B. We do the same thing here. It might be harder if I do go right in order and do 45 plus 29. So because this first one and the third one both end in 5, 45 and 55, I see I can add those together really easily. If I were to just switch around the order here, it makes life a lot easier. So I'm going to do the 45 plus the 54, which I know is 100. Then I can take that 100 plus the 29 which gives me 129. Again, justify your steps. To me, when you're actually doing these problems and showing your work, the showing the work is the justifying your steps. I don't really care if you write down associative property or commutative property. It's just we're trying to get you to look for opportunities that maybe you can do things like this, like the 45 and the 55 first, because it might make the problem a little easier for you. Okay, that's our lesson today.